Hello friends, this is Mike from Wright, and this is the explanations video for SAT 2's Math No Calculator section, question number 2. This is a systems of linear equations question. Now, if you read the question, it just gives us two linear equations and asks us for an xy coordinate that solves both equations. This is a straightforward systems of linear equations question. Here, all these answer choices are in this form of xy coordinates. So I'm going to show you two ways of doing this question. The first way is like an intentionally inefficient way that nevertheless goes along with what I tell all my students how to do systems of linear equations normally. Here we're going to use the addition and subtraction method that is usually the fastest way to do these problems. And I'm going to make a couple intentionally inefficient decisions along the way just to make sure, this is one way of doing it. It's still going to work. Then plan B is this sort of hindsight is 20/20 way of doing things. And we're going to use the substitution method, which is a different way of solving systems of linear equations questions. And we're going to make some efficient decisions along the way to make the question nice and easy. All right. So let's start with plan A. Here at plan A, we're going to use the addition and subtraction method. And the idea of that method is that we're going to solve these linear equations, this system of linear equations, by taking this equation and making it match with this equation, with one of the variables. We're going to make either the thing in front of the x match the thing here, or we're going to make the thing in front of the y match this thing here. And then by doing that, you'll be able to add one or subtract one of the equations from the other. And the ones that match, maybe the x's match or the y's match, those are going to sort of cancel out and make 0, and that sort of gets rid of that variable. Then we're going to be left with an equation that only has one or the other variable in it, maybe only has y or only has x. Then we can use that to solve for y, and then plug that value back into the equation and solve for x, and that's how we get the solution. All right, so let's see how that works here. So here's plan A, addition and subtraction. We're going to start with this first equation here. Now our goal is to get either the x to match or the y to match. There's a 3 in front of the x and a -2 in front of the y. Here I'm just going to choose to make the x's match. So you're going to do that by multiplying this whole equation, x plus y equals 0, by 3. Why are we doing that? Well, this is a 3 right here, and we want them to match, so we're just going to bring it up, bring this whole equation up to make these 3's match here. And that's what's happening. So we got 3 times 3, or sorry, x times 3 is 3x, y times 3 is 3y, and 0 times 3 is just 0. Now, what's going on in this step is this is the subtraction method step. We've brought this equation down, all the way down here, and we're subtracting the whole damn thing from this equation up here. So we're subtracting the 3 from the 3, and this is the reason why we're doing this step. The 3x minus 3x is 0, and this is nice. And then we just need to subtract the negative 2y from the 3y. So 3y minus negative 2y is the same thing as 3y plus 2y. Negative minus a negative is a positive. So here 3y plus 2y is this 5y, so this is that. And then 0 minus 10 is negative 10. So this is like the fruits of our labor right here, is this equation that only involves y's and numbers. Now we've got this clean equation where we can solve for y, and then we can figure out from there what x is. So we got 0 plus 5y equals negative 10. That's just the same thing as 5y equals negative 10. And if we have 5y equals negative 10 and we want to solve for y, well, we need to divide both sides by 5. So that's what's happening right here. We're dividing both sides by 5, and we get y equals negative 10 over 5. And then from there we know, okay, well 10 over 5, 10 divided by 5, that's just 2. So here y equals negative 2. Now we're not done, but here we want to see, let's check the answer choices to see, first off, if we're on the right track, or maybe we've answered this question already. We have enough information to answer the question. Looking at the answer choices, though, well, it looks like y equals negative 2 in A. It also equals negative 2 in B, though, and also in D. So we haven't really done that much to narrow it down. I mean, I guess we know that it's not C. And we also have sort of confirmed that we haven't made any huge mistakes yet. We're probably on the right track. I mean, we got one of these numbers, right? It shows up a lot. It's probably right. So we need to figure out not just what y is, but we need to decide, is A 3, or is it 2, or is it negative 2? Which one of these is it? Sorry, is x any of those? So we need to figure out what x is, and we're going to do that by just plugging this value into either of these equations. Let's pick the easy one, this x plus y is 0. So here, x plus y is 0. This is, we're sort of starting fresh, and we're going to plug in our value of y. This is y equals negative 2. We're going to plug that into this equation, so we got x plus negative 2, right, equals 0. This is us just substituting in the value for y. No, that's the same thing as x minus 2. X plus negative 2 is the same thing as x minus 2. So x minus 2 is 0. Let's just add 2 to both sides to get x alone, and we got x equals 2. So here, this is our xy coordinate, 2, comma, negative 2. That's answer choice B. All right, so that's it for plan A. Now, plan A was a little bit inefficient, you know. It just took a lot of steps. It definitely worked, but here in hindsight, there's a few ways that we can make this question quicker and easier. The first way looks like this. So here, this is a super duper simple equation. X plus y equals 0. I mean, this is literally question 2. This is an easy question. And one of the ways in which it's easy is that this equation is so simple. It's just one step away from being y equals negative x, or just x equals negative y. You can really easily substitute one of the variables for another. You can really easily isolate one of these variables. Now, the logic of the substitution method generally, it's like one of the main ways that you can solve systems of linear equation questions, is to isolate one of the variables inside one of the equations, and then substitute in the other side, whatever that variable equals, into the other equation. It's kind of a similar logic. You know, you want to replace one of the variables with the other one. So you put one of the variables in terms of the other one, and then substitute that in. Well, here, it works pretty simply. Here, y equals negative x, and you can just substitute that straight in. And this is what's happening here. But before we go to that, we want to decide which variable to substitute in. Here we're basically deciding, you know, x plus y equals 0. It's going to be really easy to isolate y and then replace it, or to isolate x and replace it. Here, x equals negative y, and y also equals negative x. So we have this really easy decision, like, do we want to solve for x first, or do we want to solve for y first? Which one of these do we want to substitute out? Which one of these do we want to get rid of, given that it's so easy to get rid of it? Looking at the answer choices to this question, and this is sort of like a straight-up test-taking strategy, deep strategy pro tip, you can see, and we noticed this in the last explanation, there are 3 answer choices that involve y being negative 2. Whereas with the x's, so there's a negative 2, negative 2, 2, negative 2. On the other hand, with the x's, there's a bunch of different things that x can be. Well, there's 3 different things that x can be. X is either 3, or it's 2, or it's negative 2, or it's negative 2. The chances are higher if we solve for x first, that doing so will just net us the right answer. That is to say, if we solve for x first and it happens to be either 3 or 2, we're just done, and that saves us some steps. So that's maybe some advanced reasoning based on which you could sort of decide, let's solve for x first, which is to say, let's isolate y, let's put y in terms of x, substitute x in for y, so getting rid of y, and then solve for x. So that's what's going on here. Here, we're starting with x plus y equals 0. This is just this equation right here. And when manipulating it, we're moving the x to the other side, subtracting x from both sides to put y in terms of x here. Y equals negative x. OK, now what we need to do is substitute in what we know about y is the same thing as negative x, into the other equation. So here we're sort of starting fresh again. Here, this is this equation. And then we're going to substitute in y equals negative x right here. So here, instead of saying 3x minus 2y equals 10, we're saying 3x minus 2 negative x, because y equals negative x, equals 10. Now, negative 2 negative x, negative 2 times negative x, is the same thing as positive 2x. Negative 2 negative x, negative times a negative is a positive. So this negative 2 negative x, that's 2x. Okay, so you got 3x plus 2x equals 10. That's this simplification step right here. Then for that, well, 3 plus 2 is 5. So 3x plus 2x is 5x. So this is 5x equals 10. And now we're doing the same thing here. We're just going to divide both sides by 5 in order to get x alone. And then we get x equals 10 over 5. Then from there, 10 divided by 5 is 2. So x equals 2. And here, unlike in the previous solution where we're like, oh, y equals 2, let's check our y equals negative 2, let's check our answer choices, and it didn't really work. Here we're like, oh, x equals 2. Let's see if we've solved the problem yet. And sure enough, yeah, right? The only answer choice in which x does equal 2 is B. So we can be done, you know? And that's one way that you could sort of do the question quite quickly, you know? And if you've done this, this is an easy enough problem that I think the chances are high that if you get here, you can just move on. Now that said, if you have a lot of extra time, or if you really want to be sure, you can plug it in. And this is also super quick. You can plug it in and make sure that you got the right y value as well. Here, if x equals 2, let's try to figure out what y is. We're going to do that by plugging that value of x into one of these equations. And let's just use this one. I like this one, y equals negative x. That's super simple, right? So this is what we're doing here. We're bringing it back, y equals negative x, and then we're going to substitute in our value of x. Here we know that x equals 2. We're going to substitute that value of x in. So we got y equals negative x. Well, y equals negative 2, because x equals 2. We're substituting in x equals 2. Right, so y equals negative 2. Oh, well, that's it. Y equals negative 2. And so we just get our coordinate, our xy coordinate. This is 2 comma negative 2, and that's what B says. All right, 2 different ways of doing it. All right, that's all for this question. See you in the next video.